Hello Andarki. Good morning. Diagonalization is a very important. You get 12 marks for this. It is very important for long answer. Here I'm taking the question is 1, 3, 3, minus 3, minus 5, minus 3, 3, 3, 1. So, it is a 3 cross 3 matrix. First, what is the method? How to prove the given matrix is diagonalizable? So we should follow the three steps. First step is we should find the characteristic equation from the given matrix, and second one, from the given characteristic equation we should find the eigenvalues. From that eigenvalues we find the eigenvectors. From that eigenvectors then we find the diagonalizable matrix. Okay, right? I think you got 1 point from this. Okay, so here given 3 cross 3 matrix. Now we should find the characteristic equation. How to find a characteristic equation? Did you get this down? Yes. Here I am to solve that. So this is a general characteristic equation. Yes. So this is a general characteristic equation for any given 3 cross 3 matrix. You only have to find what is S1, what is S2 and what is S3. Okay. So here for every 3 cross 3 matrix the general equation is lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. Remember it for every 3 cross 3 matrix, for not 2 cross 2 matrix. For every 3 cross 3 matrix the general equation is this is only, and you need to find only what is S1, what is S2 and what is S3. So I will tell how to find out S1 and S2, S3, right? So S1 is nothing but the trace of the given 3 cross 3 matrix. Definitely you want to know what is a trace, right? Fine, I will explain to you. Trace is nothing but the sum of the principal diagonal elements. Here how many principal diagonal elements are there? Just 3. So here 3 are principal diagonal elements. So trace is nothing but sum of these principal diagonal elements. Means here 1 minus 5 plus 1. So 1 plus minus 5 plus 1. What is plus into minus? Minus. So 1 minus plus 1 is nothing but this sum minus 3. Right? Did you get it? And what is S2? What is S2? S2 is nothing but principal diagonal elements cofactors. Here 1 is the principal diagonal element. What is the cofactor for 1? You need to cancel all these rows and columns. So this is the cofactor for 1, right? Okay, I am writing here. And what for okay, for minus 5, what is the cofactor? You need to eliminate this and this. Again 1 3 3 1. And for 1 you need to eliminate and this and 1 3 minus 3 minus 5. So here I am written. So now do the that. So you will get the answer 0. Okay, just do this. So minus into 1 minus 5 minus 3 into 3 minus. So minus into actually you know that everyone should not. So in minus into minus plus 1 into 1 1, 3 into 3 minus 9, 1 into minus minus 5, 3 into 2 9. So minus 9, and we know that for every you have the minus. So minus into minus minus 9, 4 minus 8 minus plus 4 is equal to 8 minus 8, 0. And what is S3? S3 is nothing but it is a det of the given matrix. So just do the det. You know that already det. What is that? What is det for 3 cross 3 matrix? You know, first you get plus, then after minus, then after plus. So here I got the det is 4. Hope you understand. So S1 is minus 3, S2 is 0, so S3 is 4. So this is the general characteristic equation, and put the values of the given what we got from the given matrix. So I got this equation. So this is the general equation I got. So from this equation we should find the eigenvalues. So how to find eigenvalues, let me know now, right? So now finding eigenvalues. So I got this equation. This is the characteristic equation, right? From this characteristic equation, how to find the eigenvalues? This is a main question. Of course, everyone should knows how if the given polynomial is second degree, so we can find by using splitting method. But here given is the third degree polynomial, right? So for third degree polynomial, you must and should do the trial and error method. Then you get one eigenvalue. After that, one eigenvalue, by doing synthetic division, you get remaining two eigenvalues, right? So I'm doing trial and error method from 1, so I got that is equal to 0. So therefore 1 is a one eigenvalue. So 1 from 1, so I'm doing synthetic division. So I'm writing here coefficients of the characteristic equation. There is no one term, so I put here 0. So therefore I got this 1 4 4. So I have written this second degree polynomial. From this second degree polynomial, I got lambda is equals to minus 2 minus 2. So I got two equal eigenvalues. Therefore, from all over I got here three eigenvalues. So 1 minus 2 minus 2. So if I have given 2 cross 2 matrix, you will get 2 eigenvalues. If I have given 3 cross 3 matrix, you must and should get 3 eigenvalues. If they have given 4 cross 4 matrix, you must and should get for 4 eigenvalues. So from these 4 eigenvalues, three eigenvalues, we should find out the eigenvectors. Are you ready for eigenvectors? So now finding eigenvectors. So we got lambda is equals to 1 minus 2 minus 2. So I am putting lambda is equals to 1. So this is the given matrix. So this is a question. So I am putting here 1. Therefore 1 minus 1, 3, 3, minus 3, minus 5, minus 1, minus 3, 3, 3, 1, minus 1. So I get 0, 3, 3 and minus 3, minus 6, minus 3, 3, 3, 0. So this is the required matrix when I put lambda is equals to 1. So hence totally this is the lambda is equals to 1. So this matrix I have got. So this is the matrix when we put lambda is equals to 1, and it is the value we should find what is x1, x2, x3, and it is the argument matrix. So here, so 0 for every matrix, first element, first row, first column element must and should not be equal to 0. So you need to interchange the column and column, or interchange the row and row. So I here interchange the row. So here interchange the row 1 and row 2. So then I got minus 3, minus 6, minus 3. So 0, 3, 3, 3, 3, 0. So what we should get, first we need to reduce this from the echelon form. How to reduce echelon form is nothing but, for example, reducing into echelon form is nothing but, so I am here considering some one example. So this is a 1, 3, 4, 5, 6, 7, 0, 3, 4. So I should take this as 6, okay. So this is an example matrix. So reducing into echelon form is nothing but reducing these upper matrix into 0. So making these making these three elements into 0. So this is called echelon form. Of course you can make this has to 0, this has to 0, but necessary only you should convert these three elements into 0. So this matrix we should call this upper triangular matrix, and this is the lower triangular matrix, okay. Just you got it. What is echelon form? Echelon form is nothing but reducing the given upper matrix into the 0. So that is echelon form. So I hope what is echelon form understood, right? Okay, now so here I am converting these into zeros. So here I am taking here 3 3 0 minus 3 minus 6. So I am here taking third row. So I am here converting third row. So R3 plus R1. So what we get? Minus 3 minus 6. Right, as usual R1 R2. So when I will do R3 plus R1. So 3 minus 3 plus into minus 3. So 3 minus 3 is 0. So 3 minus 6 minus 3. 0 minus 3 minus 3. Again I am converting this third row into echelon form. So again 3 minus R2. So here what we get? So 3 minus 3, 0. 3 minus 3, 0. Okay, now again, so here I converted this into 0. Enough, right? I converted upper triangular matrix into 0. Now, so I'm multiplying with this row. So what you get? Minus 3x1, minus 6x2, minus 3x3, and 0x1 plus 3x2 plus 3x3. So 3x1 plus 3x3 is equals to x2 minus, so 3x2 plus 3x3. So where 3x2 plus 3x3 is equal to 0 is nothing but 3x2 is equals to minus 3x3. But 3 3's cancel, x2 is equals to x3 minus x3. So this is x2 is equal to minus x. Okay. Now substitute x2 is equal to minus x3 in this equation. Okay. So minus 3x1. So minus 6. What is the x2 value here? x3. Substitute here. Minus 3 is x1 plus into minus, minus into minus, minus into minus plus. So 6x3 minus 3x3. So plus 6x3 minus 3x3 plus 3x3. So minus 3x1 is equals to plus 3x3 అనేది is equals to outside it will go means minus 3x3. Therefore 3 will cancel, minus minus cancel, x1 is equals to x3 we will get. So we got x1, so we got x1, x2. So now x1, x2, x3, x1 is nothing but x3, x2 is equal to minus x3 and x3 is x3. So x3 common this time, so 1 minus 1, 1. So we get 1 eigenvector. So here lambda is equals to minus 2. So from lambda is equals to minus 2, I put this minus 2 in trace. So I got this is, సో ఇక్కడ నేను R3ని తీసుకుంటున్నాను. సో R3ని తీసుకుంటే సో మైనస్ ఇంటూ ఇక్కడ మైనస్ ఉంది ప్లస్ ఉంది, ఈజీగా 0 అయిపోతుంది. సో 0. అండ్ అగైన్ వాట్ ఐఎమ్ డూయింగ్ హియర్, అగైన్ ఐఎమ్ కన్వర్టింగ్ దిస్ రో ఇంటూ 0. This row is into 0. So how can we get 0? So R2 is Q's as R2 plus R1. So again we get these two rows is 0. So there is again, so ఇది రో అనేది 0 అవ్వడానికి లేదు. సో డైరెక్ట్ నేను మల్టిప్లై చేస్తే I got 3x1 plus 3x2 plus 3x3 is equal to 0. So I'm taking common from this all 3. So again 3 is into 0కి వెళ్ళిపోతే 0. So x1 is equals to, again నాకు ఏమి మిగులుతుంది ఇక్కడ x1 plus x3 is equals to 0. సో x1 నుంచి మీద అన్నట్టు తీసుకెళ్ళిపోతే x2 minus x3. ఓకే. సో ఇక్కడ x1, x2, x3. సో x1 అంటే ఏంటిది ఇక్కడ x2 minus x2 minus x3, x2 as usual, right? x3 as usual. సో ఇక్కడ నేను x2ని కామన్ తీస్తే x3 కామన్ తీస్తే నాకు 2 వెక్టర్స్ వచ్చాయి. ఎప్పుడైతే నాకు గుర్తుపెట్టుకోవాలి, సో యూ నీడ్ టు మస్ట్ అండ్ వెన్ ఎవర్ యూ గాట్ 2 ఈక్వల్ ఐగన్ వెక్టర్స్, సో డైరెక్ట్ మీకు ఇక్కడ 3 టైమ్స్ చేయకుండా సెకండ్ దాంట్లోనే మీకు 2 ఐగన్ వెక్టర్స్ అనేది వచ్చేస్తాయి. ఓకేనా. ఇక్కడ డిస్టింక్ట్ ఐగన్ వెక్టర్స్ అయితే మీకు 3 ఐగన్ వెక్టర్స్ వస్తాయి. ఇక్కడ ఈక్వల్ ఐగన్ వెక్టర్స్ అయితే మీకు సెకండ్ సార్ చేస్తున్నప్పుడు మీకు ఇట్లా 2 ఐగన్ వెక్టర్స్ అనేది వస్తాయి. ఓకేనా. సో దిస్ ఈజ్ ద P. సో ఇది నాకు ఫస్ట్ ఐగన్ వెక్టర్, సెకండ్ ఐగన్ వెక్టర్, థర్డ్ ఐగన్ వెక్టర్, అండ్ దీస్ నథింగ్ బట్ ద గివెన్ ఐగన్ వాల్యూస్. సో దిస్ ఈజ్ ఐగన్ వాల్యూస్ we got 1 minus 2. So from this PD is equals to AP. So whenever you do AP, so you get 1, 2 minus 2 minus 6, 1 minus 2. Again whenever you do PD, so whenever you PD, so you do get same this matrix. So therefore AP is equals to PD. So whenever A is here, so P will go this segment, it will go minus. So A is equals to PDP inverse. So therefore A is diagonalizable. Hence you understood, I hope. I think this is a very lengthy video, so it is a must and should. So end వరకు చూడడానికి ట్రై చేయండి, దెన్ యూ అండర్స్టాండ్. ఇఫ్ ఇన్ కేస్ ఏమన్నా చిన్న డౌట్ ఉంటే కమెంట్ చేయండి, సో దాని గురించి మనం చూద్దాం.